Our ninth program is to find the minimum cost spanning tree of a given connected undirected graph using prim's algorithm. Okay, so let's discuss about this program. So first, see here. Before that, watch the video which I have put in the description box to know how the prim's algorithm works, and then only proceed with this explanation. Okay. So this is the graph, same graph which I have used in the video, but here I have changed the vertices numbers, so it's starting from 0. Okay, there it is starting from 1 2 like that. Okay, so it's starting from 0 1 2 3 4 5 and 6. Okay, and the weights are 10 28 14 24 25 22 12 18 and 16. Okay, and this is the same adjacency matrix as in the previous lab program we used, and all the values are written here, and we'll be using three arrays here: D, path and S. Okay, so let's look at what are these things. Before that, let's go through the class here. The class is class prim1. We are using class prim1, and this is the class here, and we have two functions here. First one is the main function, and second one is the, see, this is the main function. Okay, this is the main function, and we have the second function which is prim. Okay, this is the prim function. This is the main function which we need to know about the working of it. Okay, so let's get started from the main function. Initially we'll initialize some variables here, and then we'll be creating a scanner object to take the number of vertices here. N will be 7 in this case, and we'll be entering the adjacency cost adjacency matrix that will be to the nested for loop. And after that, what we'll be doing is we'll be initializing minimum as 999 and source as 0. Okay, and then by using a nested for loop, what we'll be doing, we'll be finding out the minimum cost. Okay, means, see here, see, observe here carefully. When you what we do is we'll be traversing this 2D array, and then what we'll be doing in each iteration, we'll be finding out the cost of ij is not equal to 0. Means when you start from here, this will be 0, this will be not considered, then this will be considered. It's not equal to 0, and cost is less than minimum. Minimum is initialized as 999, so it will be less than 999, so this will be selected. Okay, and then we'll be traversing further to see if some number is less than this one. So since this is minimum, we'll reach here, then 10 will be less than minimum, right? So then minimum value will be updated, which will be 10. Okay, so so now minimum is 10, and source will be updated as the I value. I is nothing but initially it's starting from 0, so source will be 0. Okay, so we got here 10. We'll be traversing in the same way here, and here also we'll get 10, but this will not be considered because minimum is 10. So cost of ij will also be 10 here. 10 will be less than 10, it will not work, so it will not iterate for this one. So therefore finally what we get is source as I, which is 0, and the minimum value is 10. After getting these two values, we'll be calling the prim's algorithm here, and that's it. The main thing which we need to know is after this call, the whole function gets executed from here, and finally after this function gets over, at that time the sum will be at that time it will be just printed what is the tree by using the other 2D array. Like in the previous question also I told you, we'll be storing the edges in the other 2D array, and then we'll be printing the sum also. Okay, so when these two things are printed after the prim's algorithm, we are totally focused about the prim's algorithm now. Now let's understand what does prim's algorithm do. First we'll be starting from here. We'll be initializing some variables here and arrays which I have written here. So let's see what are all these arrays for. Now see here, firstly we'll be having a for loop here. Then after that for loop, we'll be initializing some things here, and after that we'll be having the main thing. Here we'll be having this for loop which will be running from 1 to n, means n times it will run. And in this for loop we have two things. Okay, inside this for loop, see, I has no significance here, it's just for a counter. Like in the previous one we had while loop, right? It was running from 0 to n. Here it will be running from 1 to n. Okay, and what it will do is, firstly it will have a for loop inside it, which is from j will run from 0 to n. Then we will do some small line of code here, then we will run from v is equal to 0 to n. Okay, so two for loops, and in between we'll write some code. So let's understand what is this code for. Okay, so let's start from here. We'll be initializing some variables. Then this is the first for loop which we need to consider. I is equal to 0, it will run from 0 to n. Okay, and in each we are doing in each iteration we will be initializing three arrays. Okay, so let's see how to initialize these arrays. D of I is equal to cost of source and I. What is source? Source we got as 0, right? So source and I is running from 0 to n, so each value will be source and 0, source and 1, source and 2, like that, source till 6. So these all values will be stored in D of I. D of I means here we will be storing the values of these all. Now what are these values? These values are nothing but the distances from the node 0 to other nodes. From node 0 to 0 the value is 0. From node 0 to 1 the value is 28. From 0 to 2 it is 999 because there is no direct connection. 0 to 3 also 999, 0 to 4 also 999, and 0 to 5 it is 10, and 0 to 6 it is 999. So when we get these distances, what we will be doing is we will be storing these distances here. Okay, in the next line what we will be doing, s of I is equal to 0. Okay, why we have taken as 0? Because we have not visited any node as of now. Okay, s means visited or not. Okay, so here all the nodes will be initially 0, and path means path of I is equal to source. Okay, what does path indicate? D means we have the distances from the source node to all the other nodes here. Okay, from the source node to all the other nodes, what are the distances that we have stored here? And since we have taken the distances from the source node, we will be initializing the path variables as from the source. Okay, source will be 0 here. So from 0, what is the distance? From 0, what is the distance to the first node, to the second node, to the third node, like that till the 6th node. Initially it's all from the source node, so we'll be writing here the source number, which is 0, and the distances from that node here we'll be writing. Okay, and these distances should be minimum 1. Okay, means since we have just now one variable we have now, from 0 only whatever value we have we will be writing, and then after when we go in the further code we will be getting more variables here, means more nodes we will be getting and comparing. From 5 if I get a lesser value, I will be writing that number here. So suppose that from 0 to 4, see 0 to 4 it is infinite, means it is 999, right? So from 5 to 4 what I have 25. So what I will be doing is I will be updating the value here, means to 4 till 4 what is the minimum value I can go. Through 5 I can go 25, so I will be writing here 25 and updating the path here 5. So don't worry if you don't understand, we will be looking in that while considering each node one by one. Okay, so starting what we have to do is d of I is equal to cost of source and I, means from 0 node what is the distance to all the other nodes, that we will be writing down here. How we will get that? From here it's given from 0 to 0 it is 0, so we will be writing here 0. What is from 0 to 1? From 0 to 1 means from this node what is the weight? 28, so I will be writing here 28. From 0 to 2 what is the distance? It is 999, so I will be writing here 999. Okay, or I will keep it empty only, it will otherwise create a lot of confusion. Okay, so empty means it's having the 999 weight. Okay, then from 2, 3, 4 these are all 999, and from 0 to 5 it is 10. Okay, from 0 to 5 it is 10, and from 0 to 6 it is 999. Okay, that I will be keeping empty. Okay, and then what is the path? Path means from 0 I considered, right? These distances are considered from 0, so path will be from here, means this distance I got from 0, 28 also I got from 0, this also from 0 only, this also from 0, means 999 is also a distance which is considered from 0, so I will be writing here 0. Okay, after initializing the path array and D array, what we will be doing is we have to initialize s of I as 0, means s of I should all have 0, right? Because none of the node is visited as of now, so s of I will all be 0. Okay, so now s of I is also 0. Now this for loop is over. See, this for loop is over. Now we will move on to the next line of code. S of source is equal to 1. What is source? Source is 0. So s of 0 is 1. Since we can't visit from the starting vertex to the same vertex, we will be initializing it as 1. Okay, since we will not be considering that. Okay, so let's make it as 1 here. So 0 node, it will be as if 0 node is visited. Okay, then K and sum is again the same thing, means sum will be the selected arrays, the selected nodes edge will be calculated, means that cost will be calculated. For that we are using K is just a counter. Okay, so I will be not considering these both variables for the main core of this program. Okay, so I will be running from 1 to n, so that's the same thing. Will be just for the repetition purpose. We have not used the I variable anywhere inside here, so it's just as a counter. Okay, and minimum is initialized as 999, u is equal to -1. This is very important. See here, we have to make a u is equal to -1 initially. Okay, so u is very important here in this code. Okay, next what we have a for loop here, then a small snippet of code, and then another for loop. This three things will be running for 6 times, means how many number of vertices are there, 6 times will run, and we'll get the answer. Okay, so let's see how to do that now. See here, so let's see how to execute that. J will be running from 0 to n, and in each iteration one thing we'll be checking if s of j is 0 or not. What is s of j? J is running from 0, so we'll be checking each of these values. Is it 0 or not? 0 means if it's not visited, then only we will be considering that what to do with that. Okay, if it's visited, there is no use of considering, right? So first we'll be making a check of s of j is 0 or not. If it's 0, at that time only we'll be running this line of code, and then d of j is less than or equal to minimum. Minimum is initially 999, so we'll be checking the distance to jth vertex. Means see here, this will not be considered. J when j will become 1, this one will be considered. Then in this, what is d of j? D of j means distance to the first node from source. What is the distance to the first node? 28. Is 28 less than the minimum value, which is 999? Yes, 28 is less than 999. So therefore we will make the minimum value as 28 and save the value of j in u. So we got a minimum distance which is less than 999 through 0 and through 0, which is 0 to 1. Okay, so 1 will be stored in u. Okay, so let's make u as 1. Now u is 1. Now what we basically got is a minimum edge through 0 which is less than 999. So as of now, the most minimum edge is 28. We have comparisons left from 0 to 5, 0 to 4, 0 to 6, 0 to 3, 0 to 2. Okay, we'll make again these comparisons and try to find out if any more edge is less than 28 or not. Let's see. In 0 to 2, what is the value of 0 to 2? See, j will increment and j will become 2. S of 2 is not visited, so therefore we will check it if it's less than minimum. Minimum is 28. Is 999 less than 28? Means this one. 0 to 2 is 999. Is it less than 28? No, it's not. So therefore we will ignore that node. Same thing for 3 also, same thing for 4 also. But when we come to 5, what is the distance from 0 to 5? From 0 to 5, the distance is, in d of j it's given as 10. 10 is less than minimum? Yes. 10 is less than minimum means we will make minimum as 10, and then we will save the j value in u. What is the j value? J value which we got here is 5, means this edge is smaller than this edge. So we got the minimum edge here, we will be saving the u value. Okay, now what will be the u value? U will be 5. U will be 5 now. Okay, and then when we get the u value, next what we have to do? We have to do this small line of code. What is this? We will be saving that edge. See here, we compared all the edges from 0, right? This one was compared, this one, this one, this one, this one, and this one. While comparing all the edges, what we got is this is the smallest edge, means we will be selecting this edge. Okay, so let's denote that as orange line here. So this is a selected edge now. Okay, now after we select an edge, we should save this edge in somewhere in the memory, right? So that is the tree code here. Tree of k and 0 is u, tree of k and 1 is path of u. So that will save this 0 and 5 somewhere in the memory. Okay, so this edge is saved. Next, k plus plus. So since one edge is over, we will be incrementing k value, and then some will also be saved at the same time, and s of u is equal to 1. What is u? U is 5. S of u means s of 5. This should become 1 because this one is visited and selected also. Okay, so which one will select? That one will edit the value as 1. Okay, so here s of 5 will become 1. Okay, now observe here carefully what the the for loop of v. The v for loop, what it is. In here what we have is if s of v is equal to 0, means if s is not visited, then only we will be considering this, as well as cost of uv is less than dv. what is v? V is initially 0. Okay, so what we are doing is when v is 0, we are checking the minimum distance to this location, means 0 node. What is the minimum distance to 0 node? It is 0. Either from 0 it is 0 only. Okay, and then what is the minimum distance to 1? It is 28. What is the minimum distance to 2? It is 999. Okay, to 3 it is 999. Like that we are checking for all these values. Okay, while comparing these values, with whom, with which value we are comparing? We are comparing with cost of uv. See, cost of uv we are comparing with dv. dv means the distances from the 0 node, and cost of uv means what is u? U is 5. V means 5 to that node. So basically what we are doing is from 5 node we are checking for all other vertices if any distance is less than from 0 node. Okay, for example, starting from the first node, from 0 to 1 it is 28, from 5 to 1 it is 999, so it is small only we have written here. Next we will be checking from 5 to 2, from 5 to 2 it is 999, and from 0 to 2 also it is 999. Okay, so that will be written as such, means no change will be made. From 0 to 3 and 5 to 3 also same, 0 to 4, but 5 to 4 it is different. 0 to 4 it is 999, but 5 to 4 it is 25. 25 is lesser, right? When 25 becomes less, when we get a value which is less than that, see here, cost of uv means cost of 5, 4. What is cost of 5, 4? The cost from 5 to 4 is 25, this one. This one is less than from 0 to 4, right? From 0 to 4 it is 999. We have saved here 999 from 0 to 4. From 0 to 4 what I have is 999, but now I got a node which is lesser than that, which is through 5. From 5 I got the node 4 through 25. Okay, so now I should update this one because it is the minimum value. See, because d should always have the minimum value. Through 5 I am getting a more minimum value than through 0. Okay, why is 5 getting considered now? Because it's a selected edge. Wherever we select the edge, those nodes become legal to select the other nodes. Okay, when we select an edge, see, now we can't consider 1 and 2 and all because it's not selected till now. Which are selected, that one will become legal to make the comparisons. Okay, so since there was initially only 0, we had made comparisons with from 0 to all other nodes. Okay, now we have 5 also, so now we will be including the 5's comparison along with the 0's comparison. Which one will get minimum, that one will update here, and that node will be written here. In this case what we got, from 0 to 4 it was 999, now from 5 to 4 we got a minimum one, so we will be writing the path as 5. Here we will be writing 5 since we got from 5, and what is the distance we got from 5? The distance we got from 5 is 25. Okay, to the fourth node I got the I got from 5 to the fourth node. From 5 I got the distance which is less than from 0, which is 25. Okay, this is lesser node. Then after making that change, writing the minimum value here, we have another one left. From 5 to 6 it is 999, and from 0 to 6 also same only, so will not make any change. Now we have got a new minimum value which is 25 here. Next, after this, this loop is just for finding the minimum value through the legal nodes. Okay, then what we will be doing, we will be again iterating for the second time. Now while iterating for the second time, we will be initializing the minimum value as 999 and u as -1. So let's make that change here. U will be -1 now. And then what we will be doing, we will be running this loop. In this loop what we try to do is, s of j is equal to 0, we will check which all nodes are unvisited now, and then we will find out which is the minimum one. These all nodes are unvisited. See here, these are all the nodes which are unvisited, 1, 2, 3, 4 and 6. Okay, so then we will be finding out what are the minimum distances to that nodes. Okay, so what we get is which is the minimum distance to the nodes unvisited. From here I get 25, right? When you compare this one, 28, then 999, 999, 25, 999. 25 is minimum, which is the fourth node. Okay, so to the fourth node there is a minimum edge now. So then when I get a minimum edge, I will select that edge, here. So this is the selected edge now, and then this fourth node becomes legal node. Then from the legal node what we will do is, before that we will store that in some other location, then we will calculate the sum also. S of u will be 1, S of u means S of 4, since we have selected that node, so S of 4 will become 1 now. and after s of 4 becomes 1, then what we have to do is for loop. This for loop is for checking whether through 4 I will get some distance to the other nodes which are lesser than 0 or 5, means from 4 to 1 it's 999, from 4 to 6 it's lesser, right? Till now from 0 to 6 we have 999, from 5 to 6 we have 999, from 4 to 6 we have 24. So we'll make that change now. For 6th node we are getting here 24, and from which node we are getting 24? From the 4th node we are getting 24. So I'll make here as 4. Okay. Then next we are getting a node to 3, 22, which is lesser than from 5, which is 999, and from 0 also, which is 999. So I'll make that change here. From the 4th node I am getting to 3, so 3 is here. I am getting 22 through 4. Okay, I'll write here 22 and make this as 4, since I am getting that distance through 4. After that from 4 to 2 also it's same, from 4 to 1 also it's same. Now the array is updated here. Next what we will be doing is, we will be starting from here. We will be initializing minimum as 999, u as -1, and then we are doing the same thing here again, which is seeing which nodes are equal to 0. The nodes unvisited are 1, 2, 3 and 6. These nodes are unvisited. We have to find out which is the minimum node among these things, among this one. To 0 it is 28, to 2 it is 999, to 3 it is 22, and to 6 it is 24. Among this the least one is 22, means this edge is minimum. When we get a minimum edge, select it, and then 3 is selected, so we will be writing there 3. Okay, in the s of 3, s of 3 will be made as 1, right? S of 3 will be made as 1. Okay, when s of 3 is made as 1, then what we will be doing, we will be saving that things in the, means which edge is selected, that will be storing, and the sum is calculated. S of u will become 1, and after that this for loop is for checking through the node 3, can I get any other node which is lesser than the previous distances, that we will be checking now. For this what we will be doing is, we will be checking each distance here, which is 0, 28. The nodes which I have to check is first node, second node and 6th node. To the 6th node I have distance 18, but initially it is 28. 18 is less than 28, so I'll be editing this one and writing there 18. And from where did I get to the 6th node? See, from 3 to 6 what I have is 18. Okay, but initially what I have 24. From 4 I have 24, from 3 I have 18, from 4 I have 24, but from 3 I have 18. So 18 is less than 24. I'll be updating that value here. Okay, and I'll be writing here 3. All right. Here I get as 18, and here from node 3 I am getting, right? So I'll be writing here 3. Okay, and then what's our next step? After we have done for this one, we'll be checking for this one. To 2 it's initially 999. From 3 I am getting 12, so I'll be writing here 12, and from where I am getting? From 3, so I'll be writing here 3. Okay, after we have made these changes, then we'll be checking for 1. It's 999, but initially we have 28, so since 28 is smaller, we'll be keeping it as such. Okay, from 0 only it is lesser distance. So after that we'll be selecting which is the minimum one. See, we have to select from first node, second node or 6th node. From 28, 12 and 18, which is minimum. 12 is minimum. From 12, when we get the minimum value, we will be noting down this one, which is 2. So 2 is noted down and 2 is selected. Okay, when we get the minimum, we will select 2. Now 2 has become legal node. Next we will be saving the value of 2 and the sum will be calculating. S of 2 will become 1. So S of 2 we have to make as 1. Okay, since 2 is selected, we will make S of 2 as 1. Now if S of 2 has become 1, and then what we will be doing, through 2, can I go to any other node which is having lesser distance than the previous nodes which we have selected? That one we will be checking. So to which nodes we have to check? Only to 1 and 6, because those two only are remaining, right? So to 0, what is the minimum distance? To the first node, the minimum distance is 28 already. From 2, if I travel, I'll get as 16. So 16 is less than 28, I'll make that change. Through 2, I'm getting the distance as 16 to the node 1. Okay, from 2 I'm getting. Then to 6, so to 6 it is 999, so we can't consider that. Okay, then after we have updated the D register, then again we will be traversing to find out the minimum one among these all. So the only two comparisons left are this one and this one. From 18 and 16, which is the minimum one? 16 is minimum one. 16 corresponds to which node? 1, right? So 1 is the minimum one among 1 and 6. So therefore we will be selecting this edge, which is 16 here. Okay, so then we will be selecting this edge, and 1 has become the legal node. Now when a node becomes legal, we will be comparing from this one to all the other vertices. Can we get some distance which is lesser than the previous nodes? So since this has become 1, I will be selecting here 1. Now through 1 I have only I have to compare for 0. Okay, here it is already 999. From 1 I am getting 14. So therefore 14 is less than 999. So I will be selecting 14 here, and 6 has become the legal node. Therefore all the nodes are over. I will be making finally S of 6 as 1. And then when all the nodes are selected, we have to just end the loop. Okay, so finally the this graph will look like, the final graph will look like this. If you calculate all the vertices from here, that you will get as 999. Okay, and this is the same graph which you got finally as the previous ones, as the previous question, right? In the Kruskal's algorithm also, in this also will get the same graph finally. Okay, but only the algorithm is different. So when we run the code, what we get is this one. Okay, this is the minimum spanning tree. From 5 to 0, first one we selected this one, right? 5 to 0, then 4 to 5 means then we selected this one, and then 3 to 4 this one, and then 2 to 3 this one, and then 1 to 2 this one, and lastly 1 to 6. So and the sum of the minimum spanning tree is 999. Okay, so this is all what you have to show in this program. Let's move on to the next one.